Hello guys, in this video we are going to discuss about the remainder theorem. Let's learn its basics. Remainder theorem is something related to remainder, right? So let's find out the remainder. Okay, suppose I give you the polynomial p of x which is equal to 4x square minus x plus 2, and I ask you to divide this polynomial by x plus 1 and tell me the remainder. Okay, so we have learned in the previous video that we can use synthetic division whenever the divisor is of the form x plus a or x minus a. So I'm going to use synthetic division since we can apply. So I'm going to draw two lines, one like this, one other like this. Plus 1, that means I'm supposed to write minus 1 over here, right? And the coefficients over here, the coefficients are 4, minus 1 and 2, correct? Then we know first should be written as it is, then this minus 1 into 4 is minus 4, correct? Now this I'm going to add, so it becomes minus 5, minus 1 into minus 5 is 5, correct? I'm going to add, I get 7, and this 7 is nothing but my remainder, correct? So my remainder in this case is 7. Okay, I will write over here, my remainder is nothing but 7. Okay, now what does remainder theorem tell us? Remainder theorem tells us that whenever I find the value of the polynomial p at the point minus 1, that means over here it was plus 1, I took minus 1. Let's see what happens. I will write on the place of x, I am supposed to write minus 1, right? So my polynomial was 4x square minus x plus 2, I am supposed to write minus 1 on the place of x. So it becomes 4 minus 1 square minus sign, then on the place of x minus 1 plus 2. Okay, so it is what? 4 minus 1 square is 1, 1 plus minus minus plus and plus 2. So that is same as 4 plus 1 plus 2, that is 7. So that is nothing but my remainder, correct? So what does remainder theorem tells me? It says that if you just want to find the remainder, correct? If you just want to find the remainder, whenever your divisor is of the form similar to this, that is x plus a or x minus a, and you are just interested in finding the remainder, then remainder can be obtained by finding the value of p at that corresponding plus or minus a, whatever it is, right? Once I will write it properly and explain it. Let's see what the remainder theorem is. Idea is clear, yes? Whenever you want to find the remainder, whenever the divisor is of the form x plus a or x minus a, we can find the remainder easily, right? Okay, so what does the remainder theorem tells us? That if the polynomial, it tells that if the polynomial p of x is divided by, suppose I tell x plus a, you can use x minus a simultaneously, x plus a, then the remainder is nothing but p. Over here it is plus a, I will use minus a, correct? That means value of the polynomial at point minus a. Okay, so this is a simple concept of a remainder theorem which we can use really easily. Okay, one more thing. Now one more important thing that comes after remainder theorem is that factor theorem. Okay, so let's learn something about it. Some simple idea I will tell. Idea is really simple. If I tell you to divide 8 by 2, everyone knows the answer is what? The answer is 4. 2 4s are 8 and the remainder is 0. Okay, so whenever you get the remainder is 0, you say that your 8 is divisible by 2, correct? Or I can say that 2 is factor. What? The word factor of 8. Whenever the remainder is 0, we say that that divisor is a factor of that number. Okay, the same concept we can apply in polynomial also. Okay, suppose I tell you to find out something. Let's say I take an example from page number 51 in your textbook. You can open that textbook. The page number 51, example number 1, it is saying that you have p of x is equal to x cube plus 4x minus 5, and they are asking us to divide by the polynomial x minus 1. Okay, suppose I am interested in just remainder, which they have asked also. So what is the remainder? Remainder is nothing but equal to p at the point, which point it is minus 1, so I will take plus 1, p at 1, correct? Let's see what it is. So on the place of x I am supposed to substitute 1, so it is 1 cube plus 4 times 1 minus 5, so it is 1 plus 4 minus 5, it is 0. So I get to know the remainder when I divide p of x by x minus 1 is 0. So if I know it is dividing it, correct? So I know that whenever the remainder is 0, it is divided. That's why I can say that my x minus 1 is factor of the polynomial p of x that has been given. Okay, ideas are clear. We have learned two important things. One is known as a remainder theorem and other is known as a factor theorem. Okay, remainder theorem tells us that the remainder is nothing but the value of a polynomial at that point, and the factor theorem tells us that whenever you divide and the remainder is 0, then it is a factor of it. Okay, now I will go for practice set 3.5. Let's see some of an example. Before that, I will suggest that pause the video and look at some solved example. Okay, I will do some of the tricky or some interesting question from 3.5. Other will be left as an exercise. Okay, question number 1 and 2, if I see, they are really simple. We go directly to question number 4. I think that is interesting because 3 and 4 goes on the same line, so I will be interested in going with question number 4. Okay, so question number 4 is, they have given the polynomial. Suppose I give it the name p of x. Suppose p of x is a polynomial m x square minus 2x plus 3. Okay, over here x is a variable and m is another variable, but m is placed on the one place only, so we are taking as a p of x only, and m is a some constant which we have to determine. Okay, and they have given other information that p at the point minus 1 has been given as 7. Okay, and what should be the next thing? What they have asked is, we are supposed to find the value of m. What we should do? We are just supposed to write, right? We are going to use this. On the place of x, we are supposed to write minus 1, and let's see what the value of m is. So on the place of x, I am supposed to write minus 1, and the answer is 7. So 7 is same as what? P of minus 1. P of minus 1 is same as what? M. On the place of x, on this x, I am supposed to write minus 1 square minus 2, on the place of x minus 1 plus 3. So 7 is same as m. Minus 1 square is 1, correct? Minus will be plus 2 plus 3. Okay, I can do this together right now, and I can multiply this. So m into 1 is m plus 5, and over here it is 7. This plus 5 will come to this side, become in minus. So it is 7 minus 2 is equal to m. 7 minus 5 is equal to m, and that m becomes 2. Okay, so this way it is simple. Others are also simple, 1, 2, 3. You can try those. Let's do question number 5. From question number 5, let's do some of the simple one or some of interesting one. Simple one you can try. I will go with question number 5. Question number 5 says, first divide this by using the factor theorem. We are supposed to write something. Okay, we are supposed to find the remainder. Okay, so first I am going for question number 5, 3. Okay, the question is, we are supposed to find the remainder where p of m polynomial in terms of m is 54 m cube plus 18 m square minus 27 m plus 5, and we are supposed to find the remainder when it is divided by, I will just write in short, divided by m minus 3. Okay, so we know by remainder theorem, I will write in short theorem, remainder theorem, the remainder The remainder is equal to what? We know it is same as the value of the polynomial at some particular point. It is minus 3. We are dividing by m minus 3. So it is value of the polynomial at 3. Correct? So we are supposed to find the value of a polynomial at 3. Nothing else. So this is same as 54 into 3 cube plus 18 into 3 square minus 27 into 3 plus 5. Okay. So I feel this can be done. You are supposed to find the cube. To 3 cube is 27. This is 9. Then you have to multiply. Then you are supposed to add the things. So it is just a calculation that I feel you guys can do. So simple idea was clear. Whenever they ask you to find the remainder, you are supposed to use this remainder theorem. Remainder is nothing but the value of the polynomial at the point. Right? Which point, if they are given x plus a, it is at minus a. Okay. Let's do some other question. Let's do question number 7. How could we write question number 7? In question number 7, they are telling use factor theorem to determine whether x plus 3 is a factor of given polynomial or not. Okay. So suppose in question number 7, my p of x is nothing but x square plus 2x minus 3. Okay. And our polynomial, it is divided by what? It is divided by x plus 3. For factor theorem tells us that it is a factor if and only if the remainder is 0. So we are interested in remainder. So remainder is nothing but value of a polynomial at which point? It is plus 3. I am going to take minus 3. Correct? Let's see what it is. So I am supposed to substitute on the place of x minus 3. So it is minus 3 square plus 2 times minus 3 and minus 3. Okay. What is minus 3 square? Minus in the even power means answer is in plus. 3 square is 9. Plus and minus will become minus. 2 3s are 6 and minus 3. So it is 0. So by factor theorem, since the remainder is 0, by factor theorem we can say that x plus 3 is factor of x square plus 2x minus 3. Okay. So this way we can write. Easy. Okay. Now I feel which question we should do by using the factor theorem. No, let's do question number 10. It is looking bit interesting. Is divided by this, then find the remainder. It is not so difficult as such. Let's do it. Let's do question number 10. Looking interesting. Okay, any other question which that you want me to solve or something, you can write in the comment. Okay. So let's do question number 10. Question number 10 is that I hope you are open the page number 53 in your textbook. It is there on question number 10. Okay, so it is what? It is there is x raised to 31 plus 31 is divided by x plus 1, and we are supposed to find the remainder, right? One way is, if you try to think about synthetic method over here, that means there are 32 terms over here and you are supposed to say it will be easy, but it is tedious to write. So this time remainder theorem is really good, gives you answer really quickly. So remainder is what? Value of the polynomial at some point, and point is if it is given plus 1, I will take minus 1. Correct? So it is same as value of a polynomial at minus 1. The polynomial is this. So what is the value at minus 1? So on the place of x, I am supposed to write minus 1 whole raised to 31 plus 31. Okay. Minus and the odd power, answer is minus 1 plus 31. So it is nothing but equal to 30. Correct? So the remainder is 30. Simple. Okay. Which one we should do? The next is question number 11 is a factor of this. Show that this is a factor of both of them. Okay, we'll go for question number 11 even, because they are asking for finding the factor or not. Question number 11. Let's see. Show that m minus 1 is a factor of both of them. Okay. Question number 11 it is. So the polynomials, I'll write it over here. For m raised to 21 minus 1 and m raised to 22 minus 1. So it is, we want to show it is a factor. When it will be a factor if the remainder is 0. Okay. So it is divided by what? Divided by m minus 1. And it is also divided by m minus 1. So when it is divided, the remainder is what? Remainder is the value of the polynomial. If it is divided by -1, it is at 1. Polynomial is m raised to 21 minus 1. On the place of m, I am supposed to write 1. Okay, so if I write 1 raised to 21 minus 1, that is 1 minus 1, which is equal to 0. Therefore, m minus 1 is factor of m raised to 21 minus 1. Since the remainder is 0, this will be an homework. I feel you can do right on the same line. There is nothing difficult, right? It is 1 raised to 22 minus 1, 1 minus 1, 0, nothing else. Correct? Getting the idea? Idea should get clear, nothing else. Okay. The last question for this is question number 12. I'm interested. This is star mark question, means it has something interesting in it. Okay. Question number 12. They are telling me, question number 12, they are telling me x minus 2 and x minus half both are factor of the polynomial, are factor of n x square minus 5x plus m. Okay, then we are supposed to show that m and n both the value is 2. Okay, let's find out. So if they are the factor, whenever I divide this polynomial by x minus 2, if it is a factor, remainder must be 0. Okay, so when suppose I give it the name p of x, when p of x, you can write this, when p of x is divided by x minus 2, then remainder is 0. So we use that thing. So what is my remainder? Since it is a factor, we can say this, right? So remainder is nothing but the value of a polynomial. We divided by -2 at the point 2. Correct? So this should be what? It should be 0. Let's see, p of 2 is what? So it is n. On the place of x, I am supposed to write 2. So it is 2 square minus 5 times 2 plus m is equal to 0. Correct? So it is what? 4n minus 10 plus m is equal to 0. So it is what? It is 4n plus m is equal to 10. Suppose this is my first equation. On the similar way, what you are going to write? You will write when p of x is divided by this, p of x is divided by x minus half, then the remainder is 0. Correct? In that case, what you will get is the remainder is equal to p of half, correct, which is equal to 0. On the place of x, I will write is half. So I write it. So n, on the place of x, I am writing half square minus 5 into half plus m is equal to 0. So it is same as half square is 1 by 4. 1 by 4, if I multiply it, is n by 4 minus 5 by 4 plus m, 5 by 2 it is, correct, it is 5 by 2 and it is equal to 0. What I can write next is n by 4 plus m is equal to 5 by 2, correct. I can write this. After that, what I will do, I don't want this 4 over here. So we got the two equations. The first was 4n plus m is equal to 10, that we gave in the name as first equation, and the next is this, which we are going to simplify. So what I can do is I can write the same as n by 4 plus m is equal to 5 by 2. What I did, I just took this to the other side. Okay, now what I'm going to do, I don't want this 4. What I do, I just multiply the entire equation by 4, so this 4 will get cancelled. Okay, so what I get, if I multiply the entire equation by 4, this is 4 times, this is 4 times, this is also 4 times, correct. This 4 get cancelled, this 2 2s are, correct. What is left is n plus 4m is equal to 10. This is my second equation. Okay, now we are going to solve this two equation number 1 and equation number 2 by using simultaneous. Okay, so what I'm going to do, I will multiply equation number 1 by 4. Okay, what comes as, if I multiply equation number 1 by 4, what I get is 4 4s are 16n plus 4m is equal to 40. And the other equation that I has is n plus 4m is equal to 10. correct? What we used to think, we want one of the variable having the same coefficient. So here the coefficient m was 4, over here it was 1. I multiply this equation by 4, both have the same coefficient, correct? We have the same coefficient with the same sign. So I'm going to subtract this two equation. If I subtract, sign of each of them will change. So it is 16 minus 1 time n, so it is 15 times n. As we required, the one variable got cancelled, and the other side it is 30. So the value of n is 2 that we wanted. We want both of them to be equal to 2. We got one of them equal to 2 right now. So I use this value in equation number 1. What I get is 4 times n, that is 2, plus m is equal to 10. So 8 plus m is equal to 10. So what is the value of m? M is also 2. So finally we got what they have asked is, we got n and m both are same and it is equal to 2. Okay, so this way we prove question number 12. Question number 13 will be an exercise. Try to do any question. If you stuck anywhere, you can ask. Okay, thank you for watching the video. Like, share and subscribe.